All right, so we're going to start section 3.4, which is solving rational equations. Now, rational just means we're solving basically fraction equations. And we have issues when we deal with fractions if there's variables, or x's, y's, right, whatever, in the denominator. So we have to worry about excluded values, okay? Recall that excluded values are values that cause the denominator to be 0, okay? So I'm just going to put a note here. We want the denominator to not equal 0, okay? So we have to find any x value that causes the denominator to be 0 and throw it out as an excluded value, saying, okay, well, x can't be this and x can't be that. That way, when we work through the problem and we get our solutions, we can check to make sure those values are not problem values, right? Okay, so here's just a quick little recap of how to find our excluded values, okay? And we went over this a little bit when we talked about domain and how to find the domain restrictions, right? Same thing, just excluded values. We're looking where the denominator is 0 because we want x squared minus 9 in this case, right, to not be 0. So I could solve this. This is a difference of squares, right? I could bring the 9 over and do the square root, but I'm going to go ahead and factor it because remember this base is x and this base is 3 because they're both perfect squares and it's a difference, meaning it's being subtracted. This factors into x plus 3 times x minus 3. And we want that to not equal 0, right? So if I set each of these equal to 0 and solve, x plus 3 we want to not be 0, and x minus 3 we want to not be 0, then that means x cannot be negative 3 and x cannot be positive 3, because those are the two values that if we were to plug them in up here would give us a 0 or an undefined answer right here in our denominator. So here our excluded values is negative 3 and 3. Okay, let's look at another one. Same thing if we have more than one term. We just have to make sure any term that has a denominator, there's no x value that would cause that denominator to be 0. Okay, so again, I'm going to try to factor each one of these. So for this one, I want 5x plus 20 to not equal 0. And for this one, I want x minus 3 to not equal 0, right? So here, I could factor out a 5, which leaves me with x plus 4. And we want that to not be 0. Now the 5 I don't have to set equal to 0 because 5 is not going to equal 0, right? But the x plus 4, I can set that equal to 0. If x plus 4, in order for it to be 0, I would move the 4 over, right? Which means that x cannot be a negative 4. So that's the only excluded value I get from this denominator. Now I need to look at this one. If I move my 3 over by adding, right? That means that x cannot be positive 3. So notice for this problem, x cannot be negative 4 or 3. So we got two excluded values on this one as well. Okay. So on all of these, this one I did have to factor, but it was a difference of squares. The second one, I didn't have to factor other than taking out a greatest common factor. So I want to look at one where we actually have to do some legit factoring, right? So on this one, we again don't want our denominator to equal 0. So x squared plus 2x minus 8, we want that to remain non-zero. And in order to factor this one, we need to do some product, right? So our sum would be 2, our product would be negative 8, which means that we're going to use a positive 4 and a negative 2. And because our leading coefficient is a 1 here, we can use our shortcut. So we know this factors into x plus 4 times x minus 2, and we want that to not be 0, right? So we set each one not equal to 0, so x plus 4 can't be 0, and x minus 2 can't be 0. And if I solve each of these individually, I get x cannot be negative 4, and x cannot be positive 2. So my excluded values for this specific expression is that x cannot equal negative 4 or 2. Okay, so this was just a quick little review on how to find the problem values. So when you think about excluded values, think of these as problem values. Okay, these are the numbers that would give us problems if we had them for solutions. Okay, so now what I want to show you is how to solve rational equations. Okay, so we're just going to solve it like we would normally solve things, but once we get our answers, we have to make sure that none of our answers are problem values. Okay, so here's going to be our steps for solving. Steps for solving. First, we want to find all of our excluded values. Okay, these are our problem values. Okay, because if we do it at the beginning, it's best because then we don't have to think about it at the end. Okay, so we want to know right off the bat what can X not be, just so that we can have that written off to the side. Okay, then we want to make sure all of the denominators that we have are completely factored, and that will help us to find the least common denominator so that we can get rid of fractions. Okay, the way that we get rid of fractions is once we have our least common denominator, we're going to multiply every single term on both sides of the equation by that least common denominator. Because if the least common denominator is something that all of my denominators individually go into, right, divide into evenly, then if I multiply each one by it, then each individual denominator will go into that and cancel out. Okay, and I'll show you what I mean in just a minute. And then we just solve what we get after we get rid of fractions, and then we want to make sure that we check that none of our solutions are problem values, right? Okay, so let's go ahead and start by first looking for the values that we need to exclude. Okay, so values that we need to exclude are any values that cause the denominator to be 0. So if I look at this first denominator, which is just an x, the value that I can't plug in there because it would give me a 0 is just 0, right? So that means x cannot equal 0. And then I look at my next denominator, same thing. The only value that I could plug in here that would cause this to be 0 would again be 0, and we already have that one written. And then our next one, we have a 3x. The only x that I could plug into that and end up with a 0 in the denominator is again if x equals 0. So each one of these tells me that x can't be 0. So that's the only excluded value that I have. Okay. All right, so now that I know what my excluded values are, I'm just going to have those off to the side, just so that when I get done solving, I know what those values are. But I want to move into how to actually solve this equation to get our answer. All right, so our first step is to figure out what our least common denominator is. So I look at all these denominators, okay? So I'm going to go ahead and write out to the side because I'm looking for my least common denominator. Now, my least common denominator is something that has to be able to cancel out any other denominator that I have. So in order to cancel out this first denominator of x, I would need an x, right? Now I look at my second denominator. In order to cancel out this second denominator, I need a 2x. Well, I already have the x, so I need a 2, okay? And then I look at my third denominator. My third denominator needs a 3x. Well, I already have the x, but I still need that 3. Okay? And then my last term of 5 doesn't even have a denominator, so I don't have to worry about anything to cancel out there. So this is going to be my least common denominator, which if I multiply it all together is 6x. So I'm going to take 6x and I'm going to multiply it on both sides. Now, as long as I multiply by the same thing on both sides of the equation, I maintain equality, okay? So instead of just saying this whole side by 6x and this whole side by 6x, I'm going to write the 6x next to each individual term. So we're going to do 6x times 1 over x plus 6x times 1 over 2x plus 6x times 1 over 3x is equal to 6x times 5. Okay, so notice all I'm doing is multiplying the entire equation by whatever least common denominator I came up with. And the reason I'm doing that is so that I can reduce these. Notice here, my x and my x reduce, and I'm left with a 6 times the 1 on top. On this one, same thing. My x's cancel, and 2 goes into 6 3 times the 1 that I have left on top of the fraction. Okay, plus, same thing here, x's cancel, 3 goes into 6 2 times the 1 I have left on top of the fraction. And then on the other side, I don't have anything to cancel, so I just multiply these together, which gives me 30x. Okay, and then I want to combine all of this. So if I multiply all these by 1, I'm just getting 6 plus 3 plus 2 equals 30x, right? So I'm going to combine these. 6 plus 3 is 9, plus 2 is 11. So 11 equals 30x. And then I just divide the 30 off to get x by itself. So this tells me that x is equal to 11/30. Okay, and then I just want to make sure that this is not a problem value. So once I have my answer, I look back over here at the numbers I excluded, and the only thing that I said x can't be is 0. So since I got something other than 0, then this is my solution. Okay, let's look at another one. Same idea. First things first, we want to find all excluded values. So the values that I need to exclude in this case, I only have one denominator. So I just have to figure out what would make that one denominator 0. And in this case, it would be 0, right? I can't have a 0 in there. So x can't be 0. It's our only denominator. It's our only exclusion. So I'm going to go ahead and write it off to the side so that I remember to check my answer. And then I figure out what would clear that one denominator. So for my least common denominator, I want to multiply by something that would get rid of that one denominator that I have, which in this case is just an x. So my least common denominator would just be an x. Now, even though that will get rid of this one, I can't just multiply one thing by x. I still have to multiply the entire equation by my least common denominator. So I'm going to do x times this first term, which is x, plus x times my next term, which is negative 12 over x, is equal to x times my third term, which is a 1. Okay. All right, and then I simplify. X times x gives me x squared. My middle term, notice my x's cancel, and I'm just left with negative 12, is equal to, on this side, x times 1 is x. And now I have an x squared. X squared is a dead giveaway that I'm going to have to do quadratic formula or sum product. And in order to do one of those, I have to make sure everything's on one side so it's equal to 0. So I'm going to go ahead and move this x to the other side by subtracting, which gives me x squared minus x minus 12 equals 0. And now that everything's on one side and it's equal to 0, now I can go ahead and do my sum product. If sum product doesn't work, then we'll do quadratic formula. But I always try to factor first as if they're nice little numbers like this. So my sum is a negative 1, which is the coefficient of my middle term here. And my product is my first coefficient, which is 1 times my last. So my product would be a negative 12. So what can I multiply to get negative 12 that I can combine to get a negative 1 would have to be a negative 4 and a positive 3. And because my leading coefficient is a 1, I can go ahead and do my shortcut, which says this is going to factor into x minus 4 times x plus 3. Okay, and then I just solve each piece, right? So this means x minus 4 equals 0, or x plus 3 equals 0. And when I solve each piece, this is going to give me x equals 4, or x equals negative 3, right, when I move those over. So then I just have to make sure, is 4 and negative 3, are either of those problem values? So I look at my exclusions over here and notice the only thing I'm excluding is 0. So since I got something other than 0, then I can actually use both answers. So x equals negative 3 or 4. Okay? All right. So notice these two examples, we didn't actually have to do any factoring in order to easily just be able to come up with the excluded values and to easily be able to come up with our least common denominator. So I want to do a couple of examples where we might have to factor the denominators in order to find the excluded values and in order to come up with our least common denominator. Okay, so if you look on the next page, this one, a little bit more difficult, right? I first want to find my excluded values. Now the excluded values is what I need to plug in here to make this 0. So again, I want to go ahead and factor this because that's going to help me easily see what x can't be. So in order to factor this, I just have two terms and it's an x to the first power. So the only factoring I can do is to take out a greatest common factor. So if I take out a greatest common factor of 5, I'd be left with x plus 4. So this is completely factored. And once it's completely factored, now I can easily see, oh, well, the thing that x can't be, the thing that would cause this whole denominator to be 0, is if this x happened to be a negative 4. So I can go ahead and come over here, and I know that I want to exclude -4. So I'm going to say x can't be -4, because I know now if I put a -4 in here, it would cause this denominator to be 0. Now I want to look at this middle one, right? When I factor this middle one, it's a difference of squares, right? Because my base here is an x, my base here is a 4, and a difference of squares factors into the first base plus the second times the first base minus the second. So this is going to become x plus 4 times x minus 4. And notice, again, this is going to create more excluded values, because here I know that if this x happened to be a -4, it would cause this to equal 0. So a -4 has to be excluded, which I already have written. And then this one, I can't have x being a +4, because that would cause this piece to be 0, which would cause the whole denominator to be 0. So now we have that it can't be 4 or +4, sorry, -4 or +4. And then I check the last denominator. The last denominator is already as factors as it's going to be. There's nothing I can do to factor it. And I can see just by looking at it that x can't be a +4, right? And I've already written +4 as one of my problem values. So I know all the values that x cannot equal, right? So now what I want to do is figure out what my least common denominator is. And remember, the least common denominator is a denominator that will cancel out every single denominator that we have. So in order for it to cancel out this first denominator, I need a 5 and I need the quantity x plus 4. So I'm going to include the 5 and the x plus 4. That way when I multiply through by everything, right, I know this one will cancel. Then I want to look at the second term. The second denominator is x plus 4, x minus 4. So in order for that denominator to cancel out, I need an x plus 4 quantity, which I already have, and an x minus 4 quantity, which I'm just going to tack on the end here. Okay. And then for my last term, I need an x minus 4 quantity, which again, I already have. So now that I know what my least common denominator is, this is a denominator that will get rid of all 3 of these denominators. I'm going to go ahead and multiply every single term by this least common denominator. Okay, so I'm going to go ahead and say 5 times x plus 4 times x minus 4 times my first term, which is 1 over, now when I write my first term, I want to write it at I want to write the denominator in its factored form so that I can easily see what will cancel. Okay, so on this denominator it factored into 5 times x plus 4, and then I'm going to do 5 times x plus 4 times x minus 4 times my second term, which was a -1 over, and again I'm going to write this denominator in its factored form, x plus 4 times x minus 4, right, is equal to, again, 5 times x plus 4 times x minus 4 times my last term, which was 3 over x minus 4. Okay, so the reason I'm taking this least common denominator and multiplying it by every single term is to get rid of our fractions. Okay, so on the first term, you can see my 5 and my x plus 4s will cancel, and I'm left with the x minus 4 times the 1 I have on top. In the second term, both of my factored quantities are going to cancel, and I'm left with 5 times the -1 that I have on top. And then on the other side, my x minus 4s are going to cancel, and I'm left with 5 times x plus 4 times the 3 that's left on top. And now this is something I should be able to simplify, right? If I distribute this 1, I'm just going to get x minus 4. 5 times -1 is -5. And on this side, I'm going to go ahead and multiply my numbers together first, my 5 and my 3, which is 15. And then I'll distribute it into the x plus 4. Okay. So on this side, I can go ahead and combine my -4 and -5 to get -9. When I distribute my 15, that gives me 15x plus 60. And then I move my 9 to the other side by adding. So this gives me x is equal to 15x plus 69. And then I need to get my x terms together. So I'm going to go ahead and subtract 15x from both sides. And I'm going to come up here because I ran out of room. So that gives me negative 14x is equal to 69. And then I divide off my negative 14. So I end up with x is equal to, now this does not reduce. If it reduces, please reduce it. But in this case, it doesn't reduce, so we're going to leave it like that. But I am going to put the negative out front because my math lab does not like negatives in the denominator. So negative 69 over 14. And it's okay because notice the answer we got here is not one of our excluded values. So as long as it's not one of our excluded values, then it's an okay answer to have. Okay? Let's look at one more, and then I will have y'all try some. So on this first, or not the first one, it's the third one we've done. Again, we want to start by finding the excluded values. Okay? So I'm going to write over here. We are going to exclude, on the first denominator, the x value that I would plug in here that would cause the denominator to be 0 would be a positive 4, which means I can't have x equal a positive 4, right? And then on the second denominator, the x that I would plug in here that would cause issues is a negative 4. So that means x can't be negative 4 either, right? And then on the last one, just to make sure, I'm going to go ahead and factor this. Again, this is a difference of squares. My base here is an x. My base here is a 4. And a difference of squares factors into the first base plus the second base and the first base minus the second base. So now we should be able to see easily by looking at these two quantities that this one, the x can't be negative 4, which I already have, and this one, the x can't be positive 4, which I already have. So these are the excluded values that we have to be careful of. Okay, and now we can go ahead and move straight into solving this equation. So I need to look at my denominators and figure out what my least common denominator would be. So the first denominator, in order for it to cancel out, I need an x minus 4. So I'm going to go ahead and write that. For my second denominator to cancel out, I would need an x plus 4. So I'm going to go ahead and write that. And then for my third denominator, I need an x plus 4 and an x minus 4, which I already have those two written, so I don't need to write them again. So this is my least common denominator. So now that I know what would cancel out all of my denominators, I'm going to take this and multiply by every single term. Okay, so I'm going to do x minus 4 times x plus 4 times my first term, which is x over x minus 4. And then I'm going to do x minus 4 times x plus 4 times my middle term, which is a negative 4 over x plus 4. And that's going to be equal to, again, my least common denominator times my last term, which is a 32 over, and then I'm going to write it in its factored version, which is x minus 4 times x plus 4. Okay? So now every denominator should cancel out. In this first term, my x minus 4's cancel, and I'm left with the quantity x plus 4 times the x that's left on top here. Plus, on my second term, my x plus 4's cancel, and I'm left with the quantity x minus 4 times the negative 4 that's left on top of that term. And then on the right-hand side, both of my quantities cancel, and I'm left with just 32. Okay? So now this is something I should be able to multiply out and solve easily for x. So when I distribute here, this is going to give me x squared plus 4x. When I distribute my negative 4, I'm going to get negative 4x plus 16 is equal to 32. And then I combine like terms. Notice my x's are opposite, so those actually cancel out, and I'm left with x squared plus 16 equals 32. And I'm going to just solve this by moving my 16 to the other side, because since I don't have an x term now, I can solve this by using the square root method, right? So I'm going to subtract 32 from both sides. I'm sorry, 16. So I'm going to subtract 16 from both sides, which gives me x squared equals positive 16. And then to get x by itself, or to undo the square, we square root. Now when you square root, don't forget your plus or minus, right? So we end up with x is equal to plus or minus 4. And then we have to make sure that both of these answers are not problem values. So I have x equals positive 4 and x equals negative 4 that are potential solutions. But notice when I look up here at my excluded values, I said x can't be positive 4 or negative 4. So since all of the solutions that I came up with do not work, then my solution here would be a 0 with a slash through it, which means no solution. Okay, and I'm fine with you writing the 0 with a slash through it or writing out no solution. Either one is completely fine with me. Okay. All right, so on the next page, whoop, goodness. On the next page, there are 3 for y'all to try. And go ahead and pause the video so that you can work on those. Once you've done those and you're ready to be checked, or if you get stuck, unpause it and we'll go over it. Okay. All right, so let's go ahead and look at the first one. The first one, the denominators are already factored for us, so that's wonderful. So we can easily see here that x can't be a positive 1, so that's an excluded value. And here, x can't be a positive 3, so that's an excluded value. So as long as I get an answer other than those 2 things, I'm okay. If I get either or both of those 2 things, I have to throw them out. I can't use them as solutions. So then I go straight into solving. So here I only have 2 denominators, and they're both different, right? So I'm going to take those 2 denominators as my least common denominator and multiply both sides by that. By multiplying by x minus 1 and x minus 3 on both sides, on the left-hand side, my x minus 1's cancel, and I'll just be left with x minus 3 times the 2x that was on top. On the right-hand side, my x minus 3's cancel, and I'm left with the x minus 1 quantity times the 5 that was left on top. So once we distribute all this out and move everything to the same side, I'm left with 2x squared minus 11x plus 5. Now, this is something I should be able to do some product with. Some of you may have solved it using quadratic formula, and that's totally fine. Okay, either method is fine with me. I did some product, so I need to use negative 10 and negative 1 to get a product of positive 10 and a sum of negative 11. But notice here, my leading coefficient is not a 1. So I can't use negative 10 and 1 as my factors. I have to take negative 10 and 1 and replace that middle term, right? Replace that middle term so that I can now do grouping. So when I group these 2 terms, I can take out a 2x. When I group the second 2 terms, I can take out a negative 1. And now their leftovers match. So I can take out their leftovers, which is x minus 5. And I'm left with 2x from the first term and negative 1 from the second term. And then I just set each of these equal to 0 and solve, which should give you a 5 and a positive 1/2. And since neither of those are excluded, then those both are solutions to this problem. Okay, let's look at the second one. Second one, same idea. In order to find our excluded values, we need to make sure every single denominator is completely factored. The first one isn't factorable, right? And we can see that x shouldn't be negative 2. The second one is not factorable, but we can easily see that x should not be 0. So we already have 2 excluded values. And then the third one we can't really tell because it's not factored. So the way that we factor x squared plus 2x is we take out a greatest common factor of x. Once we take that out, we'll be left with x plus 2. And now you can see from each piece, this piece x can't be 0, or it would cause the whole denominator to be 0. And this piece, x can't be negative 2, or it would cause this to be 0. And both of those we've already listed. Okay. So now that we can see easily what each of the denominators are in their factored form, now we can come up with our least common denominator, which is something that would cancel out every denominator. So in order to cancel out the x plus 2, we need an x plus 2. In order to cancel out the x, we need a single x factor. And then in order to cancel out the third one, we need both of these, right? Which now we already have. So this is the least common denominator that I'm going to multiply every single term by. So when I multiply the first term by that, my x plus 2 quantities will cancel, and I'll be left with the 3x on top times the x. Okay. On our middle term, when I multiply by the least common denominator, my x's will cancel, and I'm left with the 6 that was on top times the quantity x plus 2. And then on the right-hand side, my entire denominator cancels out and I'm just left with 12. And then I go ahead and multiply out the terms so that I can simplify. 3x times x is 3x squared. When I distribute the 6, I get 6x and 12. And when I go to move the 12 from the right-hand side over, notice they cancel out. So I'm just left with 3x squared plus 6x. And that's something that I can easily factor by just taking out a greatest common factor. Once I do that, it's completely factored. So I just set each factor equal to 0 and solve. When I set 3x equal to 0 and solve, I should get a 0. When I set x plus 2 equal to 0 and solve, I should get a negative 2. And notice the two solutions that I came up with are exactly the things that I cannot have. They're my excluded values. So because neither one of them works, then it's no solution on this one. Okay? All right. Let's look at the third one real quick, and then we'll look at some formulas. So on this third one, I can see easily that my excluded value should be 1 and negative 1, just looking at the first two denominators, right? And then the third denominator is a difference of squares that factors into x plus 1 and x minus 1. So that's not going to give me any additional excluded values than the ones that I got from the first two, right? My least common denominator should be x plus 1, x minus 1. So I multiply all three terms by that. My first term will be left with x plus 1 times the x on top. My second term is left with the negative 1 that was there times the x minus 1 quantity. And on the right-hand side, everything cancels out but the 2. Okay, so when I distribute all this out, I should be left with x squared plus 1 equals 2. And then I can just move my constant over and solve by taking the square root. Okay, again, I get excluded values as my solution, right? I get plus or minus 1. I can't use plus or minus 1 because they're excluded. Therefore, no solution on number 3 as well. Okay, all right. So the last thing I want to show you is how to solve formulas. Now, formulas are exactly the same thing as equations, except we just have more letters. Okay, but we go through the same process. So I want to look at solving this formula for the given value or variable. And on this one, I have 1 over r equals 1 over r1 plus 1 over r2. And we're solving it for r2. So this is the one that we want to end up with completely isolated. Now, right now, I can't solve for r2 because it's stuck in the denominator. So I, just like the other ones, need to figure out what would be a good least common denominator to multiply all of these terms by so that I don't have fractions. So for this denominator to cancel out, I would need an r. For the second denominator to cancel out, I would need an r1. And for the third denominator to cancel out, I would need an r2. So I'm going to multiply that least common denominator by all three of these terms. So we have r, r1, r2 times our first term, which is 1 over r. And that's equal to r, r1, r2 times our next term, which is 1 over r1, plus our third term, r, r1, r2 times our last term, which is 1 over r2. Okay, so again, just taking that least common denominator of what I know will cancel out all the fractions and multiplying it by every single term. So now every single denominator should cancel out. On the first one, our r's cancel, and I'm left with r1, r2. Our second term here, our r1s should cancel, so we're left with r, r2. And then our third term, the r sub 2's cancel, and we're just left with a positive r, r1. Okay. Now again, remember, we're solving for r2. So we have an r2 in this term, and we have an r2 in this term. So I need to get the terms that have r2's on the same side. So I'm going to go ahead and subtract r2 to move it to the other side. So now I have r1, r2 minus r2 is equal to r1. Okay. So now that my r2's are on the same side, I should be able, since I can't combine these two terms, right? The only way to get R2 by itself is to factor it out like a greatest common factor. So when I factor out that R2, the first term is going to be left with R1. Second term is going to be left with a negative R is equal to R1. And then the last thing we do to get R2 by itself is we just divide off this quantity that we don't need. So we're going to divide off R1 minus R, R1 minus R. So this means that R2 is equal to R1 over R1 minus R. And we cannot reduce here because R and R1 are stuck together like glue, right? And I can only reduce if I have a multiplication on bottom, which on bottom I don't. These are stuck like glue with the subtraction sign. So since I can't reduce, I just leave it like this. Okay? All right, so on the next page, there are two for y'all to try. So go ahead and pause the video and give those a whirl. And then when you're ready, unpause and we will go over them. Okay, let's go ahead and look at the first practice problem. We're solving 1 over f equals 1 over m plus 1 over p for m. Okay, so if I want to clear out all of these denominators, then I need to multiply by f, m, and p. So I'm going to multiply every single term by f, m, p. On the first term, my f's will cancel. I'm left with mp. Second term, my m's cancel, and I'm left with fp. And third term, my p's cancel, and I'm just left with fm. Okay. So notice I have an m term on the left and an m term on the right. I need all my m's together. So I'm going to move this fm term over to the left side by subtracting. So now I have mp minus fm equals fp. And then my m terms, I can factor the m out, which leaves us with p minus f equals fp. And then to get m by itself, we just divide off that quantity we don't need. Okay. Again, we cannot reduce here because there's nothing I can factor out of p minus f. So therefore, I cannot reduce it with anything on top. Okay. Let's look at the second one. Second one, we're using this chemistry formula, which is P1V1 over T1 equals P2V2 over T2. And we want to solve it for T1, right? So T1 right now is caught in the denominator. So we're going to go ahead and clear fractions. This time our least common denominator would be the two individual denominators we have here, which is T1, T2. So we're going to multiply both sides by T1, T2. On the left, my T1s cancel, and I'm left with T2 times the P1V1 that was left on top. On the right-hand side, my T2s cancel, and I'm left with T1 times the P2V2 that was on top. So once I get to this point, remember, I'm solving for T1. So T1 is what I need to get by itself. So I need to get rid of P2V2, and I can do that by just dividing it off. But if I divide it off on this side, I got to divide it off on this side. So T1 equals T2 P1V1 all over P2V2. And that's it. Okay. All right, so that is the end of section 3.4. You should now be able to complete this assignment on my math lab. If you have any questions, please let me know.